Meanwhile, whoever is watching class 9, 10 students, you can recap the general formula for alkane, alkene, and alkyne. Alkane give up CnH2n. So I'll go from the very basic class 9 and 10. 10 students, I found your basic in organic chemistry is a bit weak. So today's topic is going to be about, again, if you have heard it before, organic chemistry. We'll go through basics, how to apply that general formula and then make the molecular formula, how to represent the organic compounds, structural formula, condensed formula, and then we'll also go through homologous series, functional group. There's a much difference between homologous series, functional group. Then most importantly, we will go through IUPAC naming, how to name organic compounds, much using IUPAC naming system, nomenclature. Okay, so let us go back to general formula. Okay, so hemaranga alkene na let's start big. So alkene, this is the first alkene member family mo. So this black one is carbon, by the way, carbon. The white one is hydrogen. So all the models I'm using, so I'm going to use, this is the carbon, white one is hydrogen. So as you know, organic compounds, the main composition, what are they made up of? It is carbon. So carbon, if you remember in class 9, there are lots and lots of organic compounds, and one of the reasons why there are lots and lots of organic compounds is because of tetracovalency of carbon. In other words, this carbon, they have 4 lapshidu 1, 2, 3, 4. Okay, so analu valency means this is the valency here. Lapshidu bate. Carbon, we know atomic number is 6. So 2, 4, last 4 you. So they need 4 more electrons to be stable. So in a way, this is the valency. Tetra, shilu lavishi. So we have 1, 2, 3, 4. Carbon ki number beru lab shiung bate. That is very important later on. Alright. Okay. Now alkane lavachin, the first hydrocarbon. Okay, let's see the general formula. If you remember, for alkane is CnH2n plus 2 same mo. So sorry, ani ulta betonda mo chingi because I'm using the front camera. So here n represents number of carbon. So same here ani 2n plus 2 naya. If the value of n here is 1, here will also be 1 bate. Okay, so this formula, general formula nale, we derive the molecular formula. This is the general formula. From general formula, we derive molecular formula. Okay, so let's see how we use this one. Now let us see this one. The first one here, the number of carbon nigamchitu n. Remember, in the general formula, n represents the number of carbon. The other carbon gamchitu chidu. So the value of n here for this structure will be 1. Now the next here, if you see here, carbon gamchitu analu 2 dumo. So here the value of n will be 2. Now if we look at this third one again, now n gamchitu 1, 2, 3. N represents the number of carbons. Right, so here n give value 3, for this n give value 2, for this n give value 1, because the number of carbon di 1 nimevatanalo. So n is the number of carbon. Now let's see here how to use this general formula. Okay, and then we'll derive the molecular formula. Molecular formula, for example, the molecular formula of water is H2O. So anzumbe, we are going to derive this molecular formula from the general formula. Okay, now let's see here. For the first carbon, CnH2n, Okay, sorry, 2n plus 2 mo. So here let us start for this first one. N gamchi do analu 1 do, number of carbon 1 do. So C1, right? So hydrogen gamchi ungo beta. Now use this 2n plus 2. 2n plus 2, this will give you the number of hydrogens, carbon chi of the hydrogen gamchi ungo be. Hydrogen gamchi ungo be. That will be given by this formula 2n plus 2. The n the value gamchi mo tato and the same n tato 1 do. So here hydrogen gamchi ungo be 2 times 1 plus 2, which is 4. So hydrogen gamchi ungo be shi ungo be when the carbon is 1, n value 1. So this is the molecular formula now. Okay, tani name kadevi penina we will see later on. Now what if the number of carbon is 2 now? In this case here, carbon ni do batemo, the hydrogen gamji ongo be now. Let's see. Carbon ni yopta, now here n gi value gamji mo 2 because number of carbon 2 me wateta. So 2 times 2 plus 2. Alkane ki general formula 2n plus 2, where n is the number of carbon ni do. The carbon ni of the hydrogen gamchi ongo. So 2 times 2 4 plus 2 hydrogen gamchi me 6 me. Let's see if we get this correct. Now let's see here. Okay, so carbon 1 2 yoptalu. Remember carbon gi lab shion lab chimo tetra covalency. So they will form 4 covalent bonds. So see here, carbon the carbon connect pe there is 1 covalent bond. The carbon ani chi gi lab chi asi 4 nani chi asi the sum go mo 1 2 3 lab. The ani lab kudi hydrogen jani te. So 1 2 3 the ani chi udalu ani carbon gi tetra covalency fulfill asi lab shi. Now this carbon ani share bimidi carbon the valency lab talu and 1 lash mo lab the toro lab sum 1 2 3 byoda ani carbon gi tetra covalency mate. Okay, so see here, do we have 6 hydrogens when we have C2? So see here, 1 2 3 1 2 3. So total we have 6 hydrogens, right? So that is how we use the general formula. The first key be watching here. Carbon chi dalu hydrogen shiungo using the formula. So see here, carbon gilab shiungo lab chimo 1 2 3 4 lab shitik tisaimo. So you can't add one more hydrogen here because carbon have only 4 arms, 4 valencies. Torochi anadi mapali mission because carbon giti lab shion, they will combine through only 4 hands. So ani the valency lamite ani. Right? So choratebe now if we have 3 carbons now, 1 2 3 carbons yoktalu, see here how many hydrogens do we need now? Use the general formula again. The C3 virgin hydrogen gamji ongove 2n plus 2 rule 2 times the n the gamjimo 3 plus 2 yoktalu 6 plus 2 equals now 8 ongove the total hydrogen 8 carbon 3 of the hydrogen 8. Let's see if this is correct. Okay, so you see here the carbon 1 2 3 do more the ani carbon nalu lab tame ana chi asi the analu khonlu sum jingo be lab mo ani lab sum go hydrogen re ki ni da 1 2 3 asi. This carbon lab ni already carbon ni chiga bindigi analu hydrogen ni jam chi yuta sum mi bate sum be ochani carbon gi lab 5 jume. That is impossible. So carbon gi 2 plus 2 betal 4 ani lab kudita you are going to attach the hydrogen. So 3 plus 2 5 yasi. Now this carbon let's see here. Carbon lu let's see here. The 1 2 3 chamchi jagove because one already arm is connected to this carbon catenation if you remember. So 1 2 3 4 5 6 7 8 hydrogen 8 yasi. So which means carbon 3 yoptalu hydrogen di 8 ongobe. So correct yasi. So this is how we use the general formula. You have to know carbon ki tetra covalency lab shion ani lab shi ko hydrogen re kya ho bate. So CN H2N plus 2 labda ani hydrogen carbon chi labda hydrogen gam chi mo ani di formula ani we use beni the general formula kahara. I hope I'm clear. Okay, so general formula alkene gi ani binita. Now alkene lavachin, I will show you a structure of alkene. Okay, so here, this is the first alkene, by the way. The alkene naludi carbon 1 the chikalu carbon chibe namchiamio, because we need a double bond, and this double bond needs to be shared with another carbon. So here we have two bonds there. Okay, so this is the first member of alkene family. All right, so double bond yobachin, we call them as alkene family. Then if there is a triple bond, and if you see it, there is triple bond here, and now one, these blue ones are the bond 1 2 3 Hanzumludi alkyne family, triple bond. Now this double bond and this triple bond, we call them as unsaturated hydrocarbon. Kachibe unsaturated labina sewachin. See here that the carbon we said they need 4 bonds more lab shion se mush. So lab ni anayasi, so analu hydrogen ni chamchi shomebate ni carbon nalu, because 2 hands is already gone there. 3 4, then 2 3 4. Now unsaturated hydrocarbon the kachibe labina sewachin, you can always break this bond here, double bond the first double bond the break bewachin. Now see here, okay, the break bemo double bond break be dalu da ani carbon gi lab thanu ga tashta ani carbon gi 1 2 3 chamchi asi. So which means now double bond the break be single bond be dalu. Now what happens is the ani unsaturated hydrocarbon gi 1 break be dalu, you can add 1 more hydrogen here. Me delen 3 plus 1 4 asi break be dalu. Now the break be mo double bond the single bond na break be the hydrogen mathame bate the 1 2 3, you can add 1 more hydrogen. Me so the complete asi kongi covalence 1 2 3 4 be asi bate. Unsaturated lami reason rani, the double bond or triple bond of the break be you can add hydrogen imevade carbon ki tetravalence hanigi. So that's why double and triple bond are called unsaturated hydrocarbon, because we can always add some more hydrogens to them. Whereas if you have this alkane here, single bond, the carbon gi already single bond to kadi break pini, you can't break it now and then add hydrogen. So that's why you cannot add any more hydrogen, because see, tetravalency is fulfilled for this carbon imeva. That's why they are called saturated. Saturated which means you cannot take in any more food imeva. So here hydrocarbon naluti, they can't take in any more hydrogen. That's why they are called saturated. So double bond ki bini. Okay, now tangachigi alkene family. The alkene family, let us go through the general formula now. Alkene general formula, if you remember, it is CnH2n. CnH2n. Tachigi alkene plus 2 di tokoi bate. Now we have only CnH2n. Here again, N means number of carbons. Here also you have to take the same value, N and the number of carbon. So like I said, alkene nalu 1 na ligumitsu, because double bonds odalu mapalera carbon ni go bate 1 na lera double bonds omitu bate carbon chi yobdalu. So this is alkene first family. Alkene gidi N di, you have to start from 2, carbon number 2. So carbon number 2 yobda the hydrogen gamchi kove 2n plus 2 di me the alkane gi sume. So 2 times n gi value the 1 man me, we have started from 2. So 2 times 2 4. So carbon ni yobdalu hydrogen shiungo be hello alkene gi. Let's see. So see alkene family, carbon, the carbon gi bana double bond yumo, carbon 2 do double bond hi, this is alkene. The hydrogen tameta. This carbon 2 bonds yasimo 1 2 the 3 4 over the carbon. So and see here you're going to add hydrogen 1 2 the any carbon hydrogen ni chamchi shoni me because carbon gi lab shilege miona chimo so 1 2 3 4 yasi. Right? So carbon ni of the hydrogen 1 2 3 4 to more. Yes? Four hydrogens when there is 2. That is how we use the general formula. Alright? So alkene gi same thing here. If you remember 2 gi double 4 more. C3 virgin 3 gi double 6. Alkene gi general form molecular formula. If the compound is alkene, you can make out from this 3 virgin 3 gi double 6, 2 virgin 2 gi double 4, hydrogen the ane be double judira jo number of carbons. C4 virgin hydrogen 4 gi double 8. See, that's how we know whether the alkene in a sekongi identify be chuachin and a 3 gi double 6, 4 gi double 8, 2 gi double 4 imo. So that's how we know whether it is alkene family. Alkene family ki the number of hydrogen di double the number of carbon. So alkene naluti double bond o and they are called unsaturated hydrocarbon because we can add some more hydrogens to them when you break that double bond, right? Okay, now double bond ki the alkene family anivi. Now alkyne family, ALKYNE. The alkyne nullity, it has a triple bond now. Triple bond. Alkyne again. The alkyne ki general formula, if you remember, it is CnH2n. The just the opposite of alkane minus 2 in the alkyne gidi. Alkane gidi plus 2. Alkyne gidi minus 2. CnH2n minus 2. Again, n di gachimo number of carbons. Right? Now let's see. Number of carbon again just like alkene. Ani C give value n the 1 nalikumitsu because they have to form a triple bond with another carbon. Carbon khorara chikara triple bond be umitsu bate. So answer be again alkyne starts from carbon number 2. Okay, so C2 bekotsani. So hydrogen da kamchi ongobe. Now it is 2n minus 2. 2 times n kamchi mo no 2e. 2 minus 2. So 4 minus 2 which is equals to 2. So hydrogen kamchi ongobe 2 ongobe. Carbon ni be the hydrogen ni. So see here. This is alkyne. Carbon ni be otalu see here. Carbon ni gi banalu triple bond 1 2 and 3. So carbon gi lab shi ongo lab chimo sum din da carbon chi khajui da analu chi chamchi ani carbon gi chi be otalu analu hydrogen re chuptalu. Now tetra covalency of carbon is proven ani carbon gi 1 2 3 4 ani carbon gi 1 2 3 4 ani the shared team ate. So see how the structure also changes, shape also changes. See linear to bate ani dimo straight be. Okay, so alkyne dianibi, that's how we use the general formula. Now this ones C2H2 ngachiya analu n ki value to beotalu thumidiloti. These are called molecular formula. Okay, structural formula condensed more. Now CnH2n minus 3. Okay, sorry, not minus 3, sorry. CnH2n minus 2. Tangachi alkyne mo ani alkyne. Then n the 3 beochin C3 beochin hydrogen comes yongo. So 2 times 3 is 6 minus 2 is 4. C3H4. 2 times 3 and 3d 6 minus 2 is 4. So this is the next alkyne member. Okay, so C3H4 any representation of the molecular formula syllabi. Molecular formula comes from general formula. I hope I'm clear. How am I watching? Let me know. Okay. Right. the alkane, alkene, alkyne ki general formula, molecular formula kadeve derive penina. That's we have seen it. Now class 10 imagine we have a whole alcohol chapter. Modani alcohol also has a general formula which is CnH2n plus 1 ida. OH tsugota alcohol nalite. OH is there. CnH2n plus 1. Now it is plus 1. So far we have seen plus 2, minus 2, and then CnH2n chamchi. We haven't seen plus 1. So CnH2n plus 1, if we break it down, this is the general formula for what we call it as alkyl family, which is represented by capital R. Okay, so R lavachi rakshi man, that's how I see it to my friend, my students. R here, it is in chemistry, it means alkyl family. So ngachi ki OH group D, it is always attached with alkyl family. If your alkyl family is attached to OH, then this is alcohol family. Okay, so any OHD we call it as functional group. We will see later on functional group lamidika china. So general formula of alcohol is CnH2n plus 1 OH. Now CnH2n plus 1 is the general formula for alkyl. YL na jutumbade alkyl de. Right, now let's use this general formula to derive the molecular formula of alcohol. Okay, so Cn again H2n plus 1 OH. OH di me OH. You have watching now this whole family is alcohol. Now Anaben you can start with 1 now. C1 you're watching hydrogen gum 2n plus 1 and 2 times 1 n give value 1 2 times 1 is 2 plus 1 CH3 C mate. So analute any 1 material to pana C1 you're watching. Okay, 1 you're watching. CH3 chamchi you watching. This is just alkyl family. The alcohol imagine you have to attach OH, and this is the first member of alcohol family. Okay, CH3OH alkyl group lo. Okay, someone said alkyl. I will go through. Tupka alkyl. Okay, so alcohol imagine. So before that, let us go through alkyl. All right, the alkyl family. Alkyl. Okay, so alkyl group D. Now the general formula D CnH2n plus 1 general formula. Okay, so N like I said it is 1. So C1 imagine hydrogen gum 2 times 1 is 2 plus 1 CH3. This is the first member of alkyl family. Then C2 imagine hydrogen gum 2 times 2 is 4 plus 1 is hydrogen 5 okay, C2H5, this is the next alkyl family. C3 imagine the hydrogen gum 2 times 3 is 6 plus 1 is 7. Now see here 3 5 7 ngachigi alkyl group D, they will always have odd number of hydrogens. Okay, so alkyl family lamidani. General formula CnH2n plus 1. First member is CH3, C2H5, C3H7. So most of the time in IUPAC nalu, this alkyl group are present as your substituent branches. Prefix the anigi 9 and 10. Right? So CH3, C2H5, C3H7 alkyl. Now any alkyl group nalu, if you simply attach OH bewachin, now this is no longer alcohol. No longer alkyl group. Now these are alcohol family. CH3OH, C2H5OH, C3H7OH. So this OH gives them this characteristics property. So now alkyl became alcohol. So handsome functional group syllabi. All right, so this is any alkyl group D. OH attached here. Now that is alcohol family. So your alcohol is always attached with alkyl family. For example, like this one here. Okay. So here, alcohol D. Now, if I break this down, ani D, this red one is oxygen. This is hydrogen. So OH mo ani D hydroxyl se labing achi or hydroxides mo hydroxyl hydrogen and oxygen. The ani D. Now let's see here. Alkyl group imemo and the carbon near virgin hydrogen gam jungulo 5 ungumo. So carbon 1 2 3 and a lab shiasi 1 2 3. So which means ana lab g empty to what any. So anidi if you remember ana luchi to watching this is alkane 1 2 2 carbon virgin 6 hydrogen alkane. Your alkyl group actually comes from alkane corresponding alkane, right? Then alkane nale hydrogen chi 10 tamachin. Now what we get is alkyl family. Okay, so alkyl D C C3 hydrogen ni bertalu alkyl alkyl D they come from alkane family hydrogen G them tamachin you get alkyl. Now which means any alkyl group nalu ani carbon gi lab ni jam chi tu ani sum bertalu lab sum do lab G empty do bade. So ana luchi gi OH group D attached chabachin. Now this is alcohol where if you take out this OH this is simply alkyl group here 3 plus 2 5 yasi bate mo. So ani bebe bodalu alcohol groups are always attached with alkyl. In this case the alkyl is ethyl mewa the carbon ni then hydrogen nga tu. So this is your alcohol humanity. Okay, the alcohol the ani desudi class 10 gi IUPAC naming I'll go in detail later on. So far we have discussed alkene, alkene, alkyne general formula and how to derive molecular formula from general formula. So let us see the exam nalu usually we ask students to write down anyway structural formula see you. We have something called structural formula F short bit then we have something called condensed formula structural formula condensed formula. So structural formula condensed formula D lavachin they will give you molecular formula will be given to you. The molecular formula di tachingache general formula na derive bimo. If you remember alkane C2 evachin C2 evachin hydrogen 2n plus 2 beotalu 2 times 2 is 4 plus 2 is 6. So C2H6 se anzum beyovachin molecular formula. The molecular formula ne de gaji information thok sawachin see here carbon gamchitu ni tulo hydrogen gamchitulo total 6 to say. That is the information this molecular formula will give you. It will tell you actual carbon atom beochin ani compound nalu gamchitu 2 ani hydrogen nalu 6. Okay, the molecular formula this will be given and then they might ask you to write the structural formula given is this C2H6. The structural formula labdalati so it's just like this one. Tangachiyana how do we represent any structural formula naludi see here we know the carbon nalu single bond bebe carbon G to semo and it's choked this our structural formula na 3D na be like this semo. They will show you the bond kasum toga mo anzumbe like this one also structural formula na di bond kasum G toga they will give you maybe structural formula. So anything at 2D nalu now C2H6 beochin you have to know this is alkane family first. How do we know C2 hydrogen 6 everchin alkane memon that only this fits in the formula. If it is alkene CnH2n C2 everchin carbon 2 everchin hydrogen 2 times 2 4 ongobe Devada analo hydrogen 6 too. So this is not alkene family. Is it alkyne? CnH2n minus 2 imo alkyne gi carbon ni abachin hydrogen gamji ongove 2 times 2 is 4 minus 2 is 2 hydrogen ni ongove. So ngachi besa hydrogen 6 too. This is not alkyne family, neither it is alkene family. So the only option we have is alkene. CnH2n plus 2 carbon ni abdalo hydrogen 2 times 2 plus 2 is 6. So this is alkane family. Hemara anishigochigi. To draw the structural formula, you have to know it belongs to which family. Alkane, alkene, alkyne. Now we have C2H6 structural formula kadebi draw bini. Now let's see. So the formula is C2H6. We identified this as alkane family. Alright, so alkane lavaji we know single bond hemara you have to draw this carbon nidu single bond me, so it is singly bonded carbon to carbon. Now carbon gi valency she, which means lab she ungolo lab chi di carbon chi bond be ani carbon gi lab da sum gove 1 2 3 the 4. This carbon also labchi anadu, so lab sum chamchi add begove phata. If you add here one more, and carbon gi 1 2 3 4 lab ngayasi, which is impossible. Carbon has only 4 valency mevade. The analu hydrogen 6 tulo, the analu hydrogen add dibani 1 2 3 4 5 6. Now this representation we call this as structural formula. Right? Structural formula lamidani. Okay. Now the next one, let us see condensed formula lamidimo. Condensed be it's a short form bitini game. Aniti t de watching chinam some time take bini but it will take up space also. Alright, the condensed naludi, the let's take this first carbon, any carbon go hydrogen gamji attached to. Sum domo analugi. For example, this is the alkene I have drawn there. Just a second. Right. Okay, so this is the C2H6 kimemo. The let's see here. Condensed, this is structural formula meva. Condensed formula kadevitini. The any carbon go total hydrogen gamchi chan 1 2 3 exactly 3. This let's take this as the first carbon. This any carbon go 1 2 3 hydrogens too. Alright. So now we are going to write as any first carbon nalu hydrogen sum jano hydrogen sum di mata subscript petsugo. This first carbon has 3 hydrogens. Now let's take up the next one. And the next carbon naya, see, we have 3 hydrogens. So next carbon naya, 3 hydrogens too. So this is how we write the condensed formula. The ani di structure kazumbe tu alkene single bond structure kadi tu. This is structural formula. This is condensed formula. The analu what you have to take care is the C2. Okay, hydrogen 3 plus 3 H6 ongo. This should not differ. Ana carbon ni, ana carbon ni, ana 6, ani 6. From this you can also write down molecular formula. From this also you can write down molecular formula carbon ni, hydrogen 6. From structural and condensed formula you can also derive molecular formula. So condensed formula lamidiyanivi. Okay, structural formula, condensed formula, representation di anivimo. Now let's try this one example here. So this is the structural formula. Okay, the structural formula of this alkene, single bond to chiara. So this is alkene. So let's take up how to write the condensed formula for this one. So this one, let us take this as the first carbon, second carbon, and then third carbon. You always have to start with carbon, not with hydrogen. Soon they'll see member to the first carbon. So this first carbon has how many hydrogens? 1 2 3 domo. So this first carbon has 3 hydrogens. So we are writing the condensed formula for this structural formula. So this first carbon has 3 hydrogens. So CH3. Right? The middle one here, the middle one carbon and second carbon has only 2 hydrogens. See, 1 and 2. So me bate. So me bachin lab nga ju memo impossible. So second carbon has CH2. The third carbon here again 3 hydrogens. So first the last key, if you remember, carbon di atara sum carbon chihalo hydrogen sum. So this is the condensed formula for this alkene here. 3 plus 2 plus 3. Let's see now. Condensed formula le molecular formula kadevitinina. So hydrocarbons umo atara and CH. And the carbon gamchitu 1, 2, 3 carbons are there. C3. Hydrogen the gamchitu 3 plus 2 is 5. 5 plus 3 is 8. So this is your alkene. This is your molecular formula. This is your condensed formula. And the structure, this one is the structure formula, which will tell you bond, single bond, double bond, but condensed formula, just at a glance, you can't tell whether any carbon the carbon gi panalo double bond to single bond to condensed formula limitation. The molecular formula is different. Okay. Yes, someone said it's propane. Absolutely correct. This is propane. Met at prop. Word to gym or tense. So propane. So next the IUPAC naming. I hope it's clear, everyone. I think it's going to be too long. My baby woke up. Maybe I'll finish up at 5. So do you want me to go through IUPAC naming, or should I go with what is homologous series and functional group? Homologous series and functional group tekaji explain benina, or maybe naming we will go through maybe in the next session if time allows. Next time. Homologous series la lo. Okay. IUPAC naming also. Kade benna. IUPAC. What should I do? Function. Okay, homologous series, I will just go anyway fast bit. Okay, so now we know the homologous series. For example, let us take alkyl group. Okay, alkyl group. Alkyl gi, we know the general formula is CnH2n plus 1. So let us find n equals 1 biochin. This is the formula of alkyl. First alkyl more 2 times 1 is 2 plus 1. So n equals to carbon C2 C2 carbon 2 hydrogen come 5. Alright. So n equals 3 biochin C3H7. Okay, my bird baby woke up. N equals 4 biochin C4 hydrogen. Each time the 2 add to 9. Now this is molecular formula. Molecular formula. Now condensed formula nan condensed formula. Okay. So condensed formula na anidi same being CH3 first key. The C2H5D CH3 CH2 because carbon ni hydrogen 5 betalu, and this is how we write the condensed formula. Then C3H7 biochin CH3, then CH2 CH2 okay, CH2 CH2 CH3 CH2 CH2 with the carbon sum hydrogen 7 C4 biochin CH3 CH2 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 So if you notice it, every time I go to the next successive organic compound, I am adding one CH2 group. And then 1, 2, 3, 4 CH2 group chi toktamachin, I get the above one CH2 CH2 CH2. The any CH2 chi toktamachin, I get the previous one. Any CH2 toktamachin, I get the previous one. Okay, so homologous series lamidi. These are series of organic compounds. See, CH3, CH3, CH2, CH3, CH2, CH2. Kondi, they are series of 1, 2, 3, 4, 5. These are series of organic compounds that have same general formula. They have same structure, and they will have similar properties, okay, in which the successive member differ by one CH2 group. See, anida aniki difference one CH2, anida ani next member ki successive lamiti nga gi shule kaatu mo successive lamiti ani meva CH3 the next member CH3 CH2 memo the analysis CH2 group chi ten tamachingagi I get the previous one or ani go this one go if I just add CH2 you get the next member of this organic compounds the CH3 CH2 CH2 so anilu we call them as homologous series which are series of organic compounds which have same general formula similar structure in which the successive member differs by one CH2 group G to watching and you could see G to be watching you get the next member remember so anilu homologous series lavi so individual member in that homologous series CH3 mo and the G CH3 CH2 and the next individual member in that homologous series is called homolog HOMOLOGUE say homolog syllabi. I hope I'm clear what is the meaning of any homologous series lamide. Alright. Now see here. This is alkene. So this is also homologous series. Remember the alkene, same general formula. This is ani 2 carbon to mo 2 carbon 6 hydrogen. Ta ani ni go chigi CH2 group chike watching you get the next series C next member of that alkene family that is CH3 thing mo ta analu 1 CH2 group G atom naman mo now you get the next successive member mebate koni gi bana difference di ani 1 CH2 tangagi anale banagi ani G CH2 group then tamachin you get the earlier member see here CH2 10 tamachin you get the previous one mo so ani zumlo next successive member naludi 1 ani CH2 group G difference ongo so me 1 carbon the 12 mass between 12 plus 1 plus 1 14 mass you are adding to the next member so ani zumlo homologous series lavi so individual member ludi we call them as homolog lavi. So that is what is homologous series. The successive member differs by one CH2 group. They will have same general formula. See the structures also they are similar. See any methane any ethane structure. See how they are arranged in space carrier single bond structure. They are similar. Then what happens is the only difference in their structure in their formula is one CH2 group. The next member gilavi the immediate member row number 1 like 2 gibana gi difference the hands of my CH2 group blue homologous series lavi. I hope it's clear love. I'm pretty tired. I don't know whether I can go with any IUPAC naming. IUPAC naming is actually easy. So maybe I'll do it for only alkene and alkene alkyne so it's pretty samey. So IUPAC naming. Okay, so IUPAC naming, remember IUPAC naming naludi there are 3 things: prefix plus word root plus suffix. Alright, suffix. The word root for example carbon 1 ebachin meth 2 ebachin eth so meth eth prop but pent hex have number of carbons that chidi give word root se longba or root word se lame tete so word root se lave ngai general way so meth searching you know there is 1 carbon eth searching 2 carbon prop ansum being word root so word root ki before there is something called prefix. Sometimes you don't have to use this prefix. Directly word root the suffix. The suffix is something the alkane imagine last 3 letter kachimo. A and E. Alkane imagine you just have to add A and E suffix now. Then E and E is for alkene, Y and E is for alkyne, YL is for alkyl, OL is the suffix for alcohol family. Okay, alcohol family. Now using this rule, okay, let us take an example, very simple example. Okay, the anidi kadevi benis watching. Let us try to name this one here. So now here, looking at this structure, kaira single bond do. So we know this belongs to which family? Single bond virgin alkane family. A and E alkane family. Mo. Now here, Anna. Straight chain do mo. Let's see here. Alkane family. One. The Anna the substituent se kanemi to ka. Substituent se kaniemi, alright? Tato I'll show you later on, you'll be clear what is substituent prefix di. So analu longest continuous chain di animeta carbon ni do mo. So word root met et. There are two carbons. So this is etime, word root etime. Okay. So word root is followed by suffix. The suffix will depend on what family you have. Right now, it's all single bond. So we know it is an alkane family. Single bond indeed. So single bond in suffix is E and E. So ani et ki sawara, you just add A and E. So this is ethane. Right? The name of this IUPAC naming, an IUPAC name of this compound is ethane. Okay, so let us see another example using substituent. Okay, so marang lagi draw again. So 1, 2, 3, 4. Okay, so always remember carbon giti labshi ongo se 1, 2, 3, 1, 2, 3. Okay, so analu toro, I'm going to add another carbon. So 1, 2, 3, analu. And the hydrogen, 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 hydrogen. Then the structural formula, if you remember how to draw isomers, now I'm sure you must have drawn a branches, something like that. So any branch of that is substituent will be present there. So anidi I will make it into condensed form. Okay. So carbon tachikalu hydrogen do C hydrogen sum do. The next nalu carbon tachika 1 hydrogen do CH then mata double bond any carbon go 3 hydrogen do. So CH3 then next nalu CH2 do CH2 and CH3 betu dana. Okay, so structure is like this. Now IUPAC naming nalu, first thing is you have to look for the longest continuous carbon chain. So for example, if I go this way, it is continuous. We are not breaking the chain. No, we are not breaking the chain. If we go that way, come back, go down, it's not called continuous. Okay, you can't break it. So ane bebe mata jure continuous, anale phata jure continuous imevade. So anale chiki longest de thugo. So longest in our case 1, 2, 3, 4. Ani the option G or 1, 2, 3, 4 straight pair to mo option nido, whichever is fine. So ngagi bewachin ani the very common imeva, everyone tries to put it in a very straight pair. Let me go this way first. So this is the longest continuous carbon chain. Tangagi analu bracket nalu be bitsudome dani. The carbon chain longest diani memo 1, 2, 3, 4. Petsub dalu. Now this CH3 group did not make it inside the Anidi shin beochin. This is the main trunk. This one is like the branches of the tree. So right now we have one branch, only one branch. Remember, the anidi we call this as substituent. The ani substituent will make up the prefix in that IUPAC naming. Prefix, word root, the suffix labdalu. Okay. The first thing is you have identified the longest continuous carbon chain. Tangaji case number 1, 2, 3, 4. Right. Now this substituent is part of this carbon here. Any carbon gilab remember that 1, 2, 3 hydrogen G any the bond imate. Any hydrogen give bond G carbon the hydrogen ni bond ni. Now this CH3 is actually sitting on this carbon. Any carbon gilab remember that 1, 2, 3 hydrogen give 4 beodala. right? Now this one is the substituent. The next step is you have to number the carbon in that parent chain, and the parent chain number, longest continuous carbon chain, this is known as the parent chain. You have to number the carbons in that parent chain. The number beodalu, if there is a substituent, in our case we have CH3 or methyl group imani. This is sitting on this carbon. The carbon on which your substituent is sitting should get the lowest possible number. Right? So, ngachi anale number bewachin 1, 2, 3. You're not going to number this substituent ki carbon. Only the parent chain na you make carbon the number bego ngachi. Okay? So, any carbon di 1, 2, any carbon number 3 jo me. On which your substituent is sitting, pale number between carbon number 3 hai. But if we number it from bottom, carbon number 1, this is carbon number 2 hai. So 3, 4. Total the 4 hai 1, 2, 3, 4. But if we number it from bottom, this carbon on which your substituent is sitting gets the number 2. So ngachi number beodalu, this carbon on which your substituent is sitting should get the lowest possible number. So which means we have to number it from bottom. Not this way, right? So this is 1, this is 2, this is 3, and this is 4, right? Now this methyl group is sitting on carbon number 2. Carbon numbering is important now. The prefix plus word root plus prefix, like I said, refers to the substituent. Okay, life will end in 4 minutes, so I think I should hurry up. Okay, we have detected inactivity or current life law. Okay, so now carbon number 2 na do. Okay, something weird is happening. Okay, all right, now carbon number 2 na lo methyl group 2. So prefix na substituent to refer beong lakchimo. So this CH3 group is sitting on this carbon number 2 now. So you have to write 2 hyphen, what is the name of this substituent? CH3 is a methyl 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 group. So prefix yasi, the 2 methyl searching substituent yasi. The next thing kachimo word root. Word root di the number beotalu last number kachimo 4 So met at prop bute bute. Now what is the suffix now? Suffix the alkene family में got a single bond. So this is A and E. So this is how we write this. 2 hyphen the to go 2 hyphen methyl butanes. Okay, so 2 methyl will make up our prefix, right? Then bute is our word root. A and E is the sub. Sorry, I have to hurry. And in live something happened, so they are going to cut off the live law and screen them the live show. My baby also work. So maybe in the next class I will IUPAC naming, I'll go in detail. Sorry. Okay, so basically prefix word root suffix pe we use baby. So if it is alkene, you just have to change E and E word root suffix the word root the carbon chain. So whenever you write the IUPAC naming, first thing is always look for the longest continuous parent chain. You have to number the parent chain number. So if there is a substituent, like in your case class 9 and 10, the substituent usually alkyl group methyl, ethyl, propyl, so any alkyl group they will sit on certain carbon ki extension so any carbon on which your substituent is sitting should get the lowest possible number. So when you number it, the substituent ki carbon got the sit the lowest number chingo. Okay, so ani the carbon number kachina do carbon number 2 na yovachin, your alkyl group is sitting on carbon number 2, let's say. So you have to write 2 hyphen tanalu number yovachin, IUPAC number nalu chigi number thomachin. You just have to know parent chain ki number carbon gadi me ani the number de. Okay, so I'll give you an example. For example, if it is like this 2 methyl, let's say butane, alright, so 2 methyl butane imagine. If you're asked to draw this structure, first I would go for and the word root kachi do bute do. Bute la carbon she me meth, eth, prop, bute. So I know it's a single bond because the suffix says ane. Alright, so when you draw it, you have the liberty to number the carbon in any way. Anale bereto, pale bereto, but you should analu number tijada mata when you write the structure. So this is carbon number 1, carbon number 2, carbon number 3, carbon number 4. Then the 2 hyphen methyl, which in this 2 refers to carbon number 2 here. So any carbon number 2 nalu gachi dulo methyl dulo. So ma single bond CH3 dumo. So shemi di kaira the chigi carbon gilab shimo 1 2 3 4 ta nalu hydrogen atom banite. So this is how we draw the structural formula from the given IUPAC name. So and the 2 lavichin carbon number 2 nalu methyl group use lame bute lavichin longest chain de 4 images. So this is how we draw the structure. So alkene imagine analu, for example double bond which ene, but just different and the number so betigo. So I think that's it guys. 55 years no. Thank you for joining. So